Hey.
Thank you for letting us into your ears. This is
Ballooning phenomenon.
Have you ever wondered how spiders fly? No? Well, let me tell you that hundreds of years ago Charles Darwin wondered the same questions, and all because one of his trips of the high seas realized that there were spiders on his boat and the situation intrigued him. That is why in the scientific bulletin we will discover and talk about the phenomenon he observed.
In 1832, a scientist and adventurous young man named Charles Darwin watched how on the ship he was traveling, the HMS Beagle, hundreds of teeny little spiders hung from short silk threads when the ship was on its way to Buenos Aires. Darwin wondered how had the spiders traveled such a long distance to reach the ship.
One explanation for this is that spiders fly with the head of the wind, which is contradictory, since the takeoff speed of the spiders is higher than the wind speed. That is why of the options we considered and began to think about the interaction of electric charges.
In order to explain this behavior, scientists consider the interaction of electric fields, whether they are positive or negative. These are attracted for other fields of opposite charge, and repel each other if they are of the same charge. In view of this, it is possible that a spider uses the force of repulsion to fly away.
The atmosphere holds a positive electric field, while Earth's surface holds a negative electric field, just like magnets with similar charges repel away from each other. And a positive charge attract, this interaction creates something called an electric field. The force of this electric field is what allows some spiders to defy gravity in a remarkable behavior called ballooning.
When a spider wants to fly, it typically climbs to the top of a plant, tiptoes around, points its abdomen in the air, and rapidly throws away a meter of silk that spreads out like a fan. All this action allows the spider to fly into the air as soon as it touches the wind.
Before flying, the spider drops cobwebs into the air. These cobwebs do not tangle because each web has a negative charge, causing them to repel each other. At the same time, the negative charge of the soil repels the spider, that has its same electric charge, making this repulsive force between the soil and the spiders greater than gravity, allowing it to fly.
We can conclude that spiders are genuine navigators of electricity in the air. When it reaches certain levels, the spider detects it, thanks to the hairs on its legs called trichobotrios, which means that before flying, spiders are electrically charged.
We appreciate your attention and we hope to wake up a bit of curiosity in you to study more about the application of the physical phenomena.
Thank you. See you soon.